Well, hi there, class. I thought I'd go over a couple of problems here to get you ready for your quiz today. Now, what we're going to be um, quizzing you on today is Chapter 13. So I'm going to come off here to the side and talk just a little bit about Chapter 13. And two of the rules of probability that we've learned are the addition rule and the multiplication rule. We've worked with these now over the last couple of classes, but let's talk about what each one of these rules is and how we apply it. Now, let's start with the multiplication rule down here. This says that if I have the probability of A and then B happening, that's going to be the product of the two probabilities, in individual probabilities of A times probability of B, if they are independent events, meaning the fact that if A occurs, it does not affect the probability of B occurring. And then the addition rule says that if I have A or B, that what we do is we are going to add together those individual probabilities if they are mutually exclusive. Meaning that there's no overlap between the probabilities. That, in other words, that the two things can't happen at once. That would mean they're not mutually exclusive. But if they are mutually exclusive, and in a Venn diagram sense, we looked at mutually exclusive as being no overlap. So, in other words, the two events can't happen at the same time. Mutually exclusive. Okay, now what we're going to do is on chapter 13, we're using these formulas here, where the addition rule is assuming mutual exclusivity and the multiplication rule independent events. Let's see how this would work on a problem like this. I've got a box and it contains 9 chips, 4 yellow, 3 blue, and 2 red. And here's what my experiment is going to be. I'm going to draw 4 chips with replacements. So that means I'm going to draw one chip, look at its color, then return to the box, shake the box up again, and then pull out another chip. And I repeat that process 4 times. The first question is, what's the probability of getting 4 yellow chips on each of the 4 trials? So what that means is we're saying, what's the probability of getting yellow, and then getting yellow, and then getting yellow, and then getting yellow? Well, the multiplication rule says that if I'm doing and combinations, yellow and yellow and yellow and yellow, it's going to be the probability of yellow times the probability of yellow times the probability of yellow 4 times. Now, are these independent events? Well, since I am pulling a chip out and then returning it to the box, yes, the probability of getting yellow is going to stay the same each time. So the outcome of one of these events, one pull, doesn't affect the probability of the next one. So they're independent events, and that's my formula. So this probability of getting y and y and y and y would be the probability of y, and then raise that to the 4th power. Now, the probability of getting y on one pull is obviously 4 out of 9, because there's 4 chips out of 9. So this means then that I've got a 4/9 chance on one pull of getting yellow, and I raise that to the 4th power. That means I'm going to take 4 divided by 9, and then raise that to the 4th power on my calculator, and I get 0.039. Or 3.9%. Now, the interpretation of that is that if I repeat this experiment many times. The experiment being 4 poles with replacement. About 4% of the time that I do that experiment, I will expect to get all yellows. So not very often, but 4 out of 100 times I could expect in the long run to get 4 yellow chips out of 4 out of 4 chips that I pull sequentially. Okay, let's go to the next one. What's the problem of getting all blue? Well, that's a very similar question to what we just did. So that's going to be blue and blue. Get rid of that. Blue and blue and blue and blue. Well, that's going to be the probability of pulling a blue chip on one pole repeated 4 times to the 4th power. Now, there's 3 blue chips, so that means there's a 3 out of 9, or 1/3 chance. So I've got 1/3 raised to the 4th power. So on my calculator, 1 divided by 3, that's my 1/3, raised to the 4th power. I get 0.0123. Oh, sorry, put that in the wrong spot there. Get rid of that. So I've got 0.0123 here. 0.0123. So about a 1.2% chance in the long run of getting all blue chips. Okay, let's talk about this next one. The probability of getting at least 1 yellow. And what we saw last week when we were working on our group exercise is the probability of getting at least 1 yellow. So that means on my 4 poles I get either 1, 2, 3, or 4 yellows. Now, what's the opposite of that? The opposite of that, or the complement of that, is getting no yellows. So what I can do is I can say it's 1 minus the probability of getting no yellows on all 4 poles. So what I need to do is figure out what is the probability on one pole of getting no yellows. Well, because I've got I know the number of chips that I have. I've got 4 yellow chips. That means 5 of them are not yellow. So I've got a 5/9 chance on any one pole of not getting yellow. That means then that the probability of getting no yellows on 4 poles would be 5/9 raised to the 4th power. And 5/9 to the 4th power, 5 divided by 9, raised to the 4th, is a 0.0953. That means the probability of at least 1 yellow is going to be 1 minus that probability. 1 minus 0.0953. So I've got about a 0.905. This would be so that ends up being 0.905, or about a 91% chance of getting at least 1 yellow out of 4 different poles. Okay, let's do one more here. The probability of getting the first yellow on the 4th try. So that means then that I'm talking about the sequence of getting no yellow, and then no yellow, and then no yellow, and then on the 4th pole, I get a yellow. So I will say, and then yellow. Now these are all independent events, so that means by the multiplication rule, my answer is going to be found by taking the probability of no yellow times the probability of no yellow times the probability of no yellow times the probability of pulling a yellow. Now what are those probabilities? Probabilities of not getting yellow is 5 nights. Probability of getting the yellow is 4 nights. So basically what I have is 5 nights to the third power multiplied by 4 nights. And that's going to be my overall probability of that sequence of events. No yellow, no yellow, no yellow, and then yellow. We'll do that on our calculator. So we do 5 divided by 9. I raise that to the third power. That. And then I'm going to multiply that by 4 and then divide by 9. And I get 0.076. Or a 7.6% chance that I won't get my first yellow until my 4th try. I think that about does it. We'll go ahead and do your quiz now. Just as a reminder, the Chapter 14 MathXL is due Friday if you have not done it already. The MathXL Chapter 13 was due last Friday. What we're going to do next week, just so that you know, so what we'll do here, so Friday, we'll continue Chapter 13 and 14, do a little bit more on that. And then next Tuesday, we'll do a practice test. And then my plan then will be on Thursday to do a Chapter 13 and 14 test. Now, I guess as I'm sitting here, this might change possibly. It depends on what the schedule is for our semester exam. So it's not etched in stone, but just be prepared for it. That may be the day that we do it, and I should be able to tell you on Friday. Okay. Good luck on the quiz, and I'll see you all on Friday.